No, Bush. It's all Bush's fault. You can't blame anything on Obama. He'd like Bill Clinton. Alrighty, got that going. And I think we were doing the inverted. We were doing the sideways cylinder. Did we finish it or what? No. Testing. Yeah. A little thing over meter going across there. Battery. I want to do the inverted trough. I want to do that. Well, I know I did it. Was it 4 foot by 12 foot? 10-foot pipe? Yeah. Okay, that's what I did. Insert media. There we go. How's that? Alright, there's our tank. And I think we've got a radius of 4 feet. And we've got a length of 12 feet. Now let me know about, I hope I got the right problem. And we've got a pipe at the top of it. That's 10 feet. And it's going somewhere. Okay. And I think I told you it was full of, and I think we came up with fuel, full of fuel. I don't have what was in it because I know that OIL is heavier than water, but gas is not heavier than water, I don't think. I think water is like 65 pounds per cubic foot. Anybody know? Yeah, center, so it'd be lighter probably. well, I don't have what it is. It's full of a liquid, and don't ignore that blue part there because it's full. Full of fuel at 42. You all right? You gonna be all right? You need to lay off them Marlboro Reds. 42 pounds per cubic foot. And they want to know how much work it'll take. Just think of your plunger right here, and you're going to push it where? Right there. I always get students. One student said, well, I thought you got to pump all the water to the top of the pipe. And I'm going to see you take this VA plunger right here, this 12 foot by 4 foot or by whatever foot plunger, and make it go in that little bitty pipe. Can't get a square peg in what? Round hole. So you can't. So there's going to be some residual liquid in here, but that's minimal. But they don't care about that. They want to know how much it takes to lift that water or that fuel. Stuff like that. So again, we take our handy dandy virtual pen and draw a plunger, and that plunger is going to look like that. And of course, this is what is important right here, because the 12 foot stays what? It stays 12 foot, so you don't have to worry about that. So we're going to focus on this guy. I don't know if I remember covering a little bit of this, but I can't remember what we covered, so I'm just starting from the beginning. So we're going to look at this end right here. That's just about perfect. Don't stop. And we've got a diameter there, and a height here, and of course it's with a circle, so you're going to use a squared plus b squared is equal to c squared. And I came up with, if you want to find c squared, it's going to be c squared is equal to, or not that, a squared, I'm sorry, a squared is equal to c squared minus b squared. A squared is equal to c squared minus b squared. And we'll call a squared w over 2. And c, we'll call that 4, because that's the diameter. So we'll go w over 2 quantity squared is equal to 4 squared minus, and for the b, would be the h. And you don't have to call, you can call this diameter over 2, you can call that diameter over 2, whatever you want to call it. Okay? Because the diameter is divided by 2. Or you could put, you're trying to find the relationship between this guy and this guy right here. Now you could put it in terms of diameter. You could. In this problem, we're not doing it that way, but you could do that. But that's why I'm divided by 2. So, square it, it's going to be w squared, and solve for w. So let's just take this, let me move it. And that'd be w squared over 4. Is equal to 16 minus h squared. And multiply both sides by 4. That's going to be w squared is equal to 4 times 16 minus h squared, and then take the square root of both sides, and that's going to be w is equal to 2 times the square root of 16, the square root of 16 minus h squared. Square root of 16 minus h squared. 8 minus what? What do you mean? No, that's the difference of two squares right there. So you got to do 8 plus 8, 4 plus h, 4 minus h. You don't just, nothing's that simple. Remember, so you can't just go 4 minus h. So that's our relationship. So now you take that. What is the volume of this slice? I'm not being rhetorical. I'm asking one question. Length times width times. You know, you go to this one there. Alright, the height is dh, or dx, or whatever you want to call it, dy. Alright, so that one, you know what that was, dy. Now, length is what? I'll do that one for you. 12. So what's the width? Right here. So we did get the diameter by using WO2. See? That was answering your question a while ago. So we've got diameter. Alright, so that goes in here. 2 times the square root of 16 minus h squared. So this is going to be dh. I really don't care about that. Okay, so now we need to take the volume, multiply it by the density, and you can also multiply that 12 times that 2. You can do that to get your force of your slice. So let's do this. Let's take good. Of course, just leave one little thing out. I tell you what, y'all gonna be engineers, right? You know what y'all need to design? A dadgum smart board that works like CAD instead of the opposite of CAD. Alright. So let's go with the force of the slice. Force is equal to what? Well, density, or in this case, the density times what? The volume. Okay? So that's basically what you're doing. The volume of the slice. I mean, not the volume of the slice. The force required to move that slice. Because it's made up of, you know, it's, even though it looks like a piece of plastic or a piece of metal, it's really not. It's made up of the density. So that'd be 42 times, I'm looking for it, where is it? There it is. 12 times 2 square root of 16 minus h squared dh. Okay, that's the force. Now, what do you multiply with force? Distance, displacement. Now, you are pumping. You are pumping. Just remember this. You are moving this liquid here and where else? Here. Now, it may not be the amount that you're moving here, but you've also got to include, you also got to include that distance of 10 feet in your calculation. So set up your integration. And like I think I told y'all last time, since you're pumping from the bottom to the top, you're going from -4 to what? +4. And that's setting the grid. In some books, I don't know whether this book even has this problem in here. This is the way they set it up. They set it up on an XY coordinate. That's why. Well, the integration is for the plunger. How far does the plunger move? No, not the plunger. The plunger moves from what? -4 to what? To 4. So that's where your integration is going to be set up. Your 14 is going to come somewhere else. This displacement or distance. Be 14 minus h. So work is equal to the force, all of this, and you can multiply the 2 times 12 times 42, multiply that out, and then multiply by your displacement, which is going to be 14 minus h. Wouldn't be 14 minus h. It would be 18 minus h, would it not? Yeah, because that's 8 feet right there. 8. So it'd be 18 minus h. Evidently it was half full. Oh, well, I'm going to do a full one. So what's 42 times 12 times 2? Somebody crank that out. Is it 1,008? Yeah, I did that right. 1,008 times square root of 16 minus h squared dh. And then that's your force times your displacement. And your displacement, we say, is 18 minus h. And now that is, now all you got to do is put your integration symbol on it from -4 to 4. You're ready to go. Right, Mr. Fowler? I'm going to write, I'm going to do the actual integration right here, and then we'll move it to the next page. So, work is equal to the antiderivative from -4 to 4 of 1,008 square root 16 minus h squared dh, we put dh at the end, times 18 minus h dh. There is your antiderivative setup. So again, we kind of followed the same rule we did with the conic section, did we not? What did we do first? Well, we drew a picture. But what was the most important part? The diameter relationship, right? It's right here. Let's just, all right, here. Wouldn't you say that that's the most important part? Especially with the conic, well, with the conic and the cylindrical and the spherical, wouldn't you say that's the most important part? Yes, Hubert. Thank you, class. Thanks for the interaction. Makes class go by a whole lot better. So let's take it over to the next page. And then 3, start setting up your force and then your work. Set up force and work. And then once you set up the force and the work, then you need to look at the parameters and the what? Displacement. And then once you do that, you're ready to set up your whole integration. And then you sit there and stare at it for 15 minutes, right? Well, you know what the alternative is when you get stuck on a problem. What's the alternative? There you go. You're learning. That way you can later live where? In a ditch. Yeah. Shanty. Aren't we? I didn't know what a shanty was till I played in Annie. I was in Annie and I found out what a shanty was. Dang old Hooverville. Yep. No, it was Bush's fault. I don't know, was Hoover a Republican or a Democrat? Anybody know? I think he was Republican too because... And that's what threw us into a depression, yeah. You think we'd learn from that, wouldn't we? But back then, a Democrat was a different Democrat than it is now.
It was the same Democrat. The Republican-Democrat switch occurred right after the assassination.
Ah, okay. Well, I'm talking about down south, because my grandfather, both my grandfathers were like diehard Democrats, and they don't believe the same thing that the Democrats now believe. They were dadgum. They should have been Republicans, but they would never commit themselves to Republicans, but they voted Democrat. But some of the Dixiecrats were dang old Ku Klux Klanmen too. Some of them were just racist. Yeah, I think we ought to quit.
How would you solve that?
Well, the first thing you do, what's the first thing you do? There's two things that are just elementary. Huh? Besides quit. Cry, yeah. Do that.
Pull out.
Take the 1008 out. Now you may think that's trivial, but oh my gosh, when you get to FEQ, that's one of the first things you do in every single problem is you pull out all you can. So let's pull out the 1008. So equals 1008 antiderivative -4 to 4. What's the other elementary thing that you should do?
Switch your
Radicals and calculus what? Don't mix. So switch it. That'd be 16 minus h squared to the 1/2 power times what? Okay, now you've got it down to the bare basics. Now what do? Let me change one thing. Let me take this out. Let's see if I can do this. Let me just erase it. And change it to a 4. No, not a 4. Let's change it to a... What do you do now? So what do you do with that? Now you can't distribute this way, can you? You can distribute this way. And then you feel good about yourself. You might wear sunglasses in the building. Did you see somebody do that? Yeah. I take my glasses off because these lenses are supposed to be state-of-the-art lenses. And it takes them twice as long to go back clear when you've been out in the sun. I take them off because they look like sunglasses. And I'll take them off when I go in the building. Run into a couple of holes, but other than that, you know. Yeah. Run into the pole, you don't look like an idiot, but I'm sorry. What do you call these things? What do you call that thing out there? Wall? Column. Thanks. Walking into a column, you know, Walmart, walking into one of the columns. I'm sorry, Tarzan. That's right. 1008. Antiderivative of -4 to 4. 18 times what? Or 16 minus h squared to the 1/2 power times 18 minus 16 minus h squared to the 1/2 power times what? H and then dh on the end. Now you can break it up as two what? Two separate integrals. Now the radical might help you when you break it up into two separate integrals because then you might have the arc sine, which you can go back in your integration tables and find it. That might be arc tangent. I don't know which one it is. I'm just saying, I don't know. I just know that when you break it up into two and put the radical back in, you might be able to manipulate it. I think it's the arc sine. Maybe the arc. I think it's the arc sine. I didn't carry it that far. Look it up. And the second one, I think, is probably going to cancel. So that 14 is going to come out. I'm sorry, not 14. Let's see. 18 is going to come out. So break it up as two integrations. or integrals. Leave the 1,000 out front. 1,008, sorry. And that's going to be the antiderivative, -4 to 4. And that 18 is going to come right out here. And that's going to leave you with 16 minus h squared to the 1/2 power dh minus antiderivative -4 to 4 of h and 16 minus h squared to the 1/2 power dh. Well, what is the derivative of h squared? -2h dh. Well, that'd be a negative right here and a what? -2 right here and what? What out here? -1/2. And I just saw that right there. So basically you got u du, but the u, it's going to cancel out because it goes to 0. But go ahead and finish it because I got to copy that over to the next page. Look up the square root of a minus x squared. Yeah. What is it? Is it the arc sine?
I feel like that would be true, so the large sign would be a fraction.
Let me pull it up. Hold on. I fixed my grade book. You have to go in and fix your grade book. Everybody's failing, so. You can't go by those grades. That's just graded on your homework. We ain't even done a test yet, so. Do the integration table. I don't know where the integration table is. Well, it might be in the appendix. Let me look in the appendix. Contents. I would ask y'all to tell me the page, but y'all don't have the book, so. Alright, it would tell you where it should be in the back. Nope. Oh, there's the index. Where's that? Okay, we're getting there. Table of integrals. Don't know where the arc sine is. I'm having to look for it. So a squared minus u squared. Is that it right there? Y'all help me out. A squared. Yeah, that'd be 4. And that'd be h. Yeah. I thought it was arc sine. Or inverse sine. And if I gave you this on a test, I would put a hint in there that, you know, arc sine. I wouldn't say, okay, you're on your own. Do you see where you see it? See a squared and u squared. A squared minus u squared. Take 14 out. And basically you rewrite it as this. Or are you thinking of the derivative?
I was just trying to do it by choosing stuff.
It'd be kind of difficult to do that.
Yeah.
Because of the, huh?
That's what I'm finding.
Because of the minus. That would throw a monkey wrench in it. Alright, rewrite it. Thing on what? Thing on h over 2 square root, of course, of what we got, plus thing on 16 over 2, which is 8, inverse sine of h over 4 plus c. Is that what y'all got? Yes, you were. No, you were. Well, let me do this and this. And what do we got? We got the antiderivative of the square root of, what is it, 16 minus what? H squared? Is that what we got? So that is the antiderivative of 4 squared minus h squared. So a is equal to 4 and u is equal to h. And now it's just plugging what? So h over 2 square root of 16 minus h squared plus 4 squared is 16 over 2, which is 8, inverse sine of dang old h over 4. Okay. That's what I got. Let's see. H. I got the 1/2 there. H over 2, 16 minus h squared plus. Okay, I factored the 1/2 out. But you can do that. Yeah, you can do that. Factor the 1/2 out and put it with the other numbers. It doesn't hurt anything. Eight divided by 1/2 is 16, right? Yeah. So you factor it out of 1/2. Okay. So that's the only difference in mine. I factored out the 1/2 to make this h fall down. So let me just show you what I got. Let me save this right here. There's this page and there, back, and Okay, now I'm a firm believer in taking everything you can out. So when you change, what happened to my 1/2? Is this 1/2? And this is 1/2. And this is minus. We good? Took out my 2s and my 1/2 here. Alright, y'all check me. Is that good now? That's supposed to be 8 squared. Anything else the stupid technology took off? Where's 18? Anything else? Alright. Now, this turns out to be what? What is this? U to the 1/2, so that's going to be to the what? Plus 2 halves, that'd be 3 halves over 3 halves, right? Is that what you get? Because you have U du. So let's rewrite that as 1018 bracket or parentheses, this trash, right there. We good? Minus, this comes out to be 16 minus h squared to the 3 halves over 3 halves, right?
Yeah.
I forgot the word. Oh, 2. 2 right here. Okay. That good? All right, now, clean everything up, but you're going to end up seeing, and I just forgot my -4, I just dropped it off somewhere. This is going to go out. Basically because 4 plus 4 squared. And what's 16 minus 16? So, hooray, that does what? That goes out. So you can do it now, do it later, I don't care. That goes out. Alright, so I'm just going to focus on this right here. So I'm going to go 1,008. I don't know why I keep calling it 1,000. And that's going to be 18. Evaluated at -4 and 4. Now, I can factor out a 1/2 right here and right here and pull it out here. So that's what I would suggest, unless you just want to work with fractions. So that'd be 1,008, 18 times 1/2, and that'll leave h times the square root of 16 minus h squared plus 16 inverse sine of, let's see, that takes it out of there, that stays h over 4 at -4 and 4. So now all we got to do is what? Plug and chug, right? Now, that first part right there, that's going to cancel out. But you got a plus here, so it's not going to cancel out everything. So let's take that over to the next. Well, I didn't do the math. I just did it. I got 1,008 times 4 times 8 pi. In other words, I didn't do the math, so I just wrote it in terms of pi. So it's not going to let me copy it, huh? is that supposed to be? H, is that, what is this? Is that anything? That's just, okay. Let's just do this. Let's do this again. And let's leave the 1008 out front. Right? You got to put a minus. I'm trying to cut down a couple of steps if you're wondering. And remember, we do what? Minus. Now wherever there's a H here, I'm going to plug in forward. Make sure I didn't mess up anywhere. So that H goes out, that H goes out, that H goes out, and we replace it with forward here, and is there forward here? Okay. And then -4, so that's going to be, take it out here, here, and here. And that's -4, -4, and -4. And let's see what happens. All right, what happens here? That's 0. 0 takes that out to 0. 0 takes all of this out, right? It is. I'm looking, yeah. So I can pull the 18 times 1/2, I can pull it out with the 108. Is that what you're saying? Okay. Huh? Pick up. Well, there it is right there. I can pull it out. That's 9. Pull it out here. Is that what you're saying? Let's just pull it out. And take this out here. And then, is that okay with everybody? That still goes to 0 right here. And then we left with 9 times 1008. And I'm just going to put brackets. 16 inverse sine of 1. Minus parentheses 16, and this turns into a 16. 16 minus 16, so that goes out to 0. And then we have 16 inverse sine of -1. Inverse sine of -1. Make sure I didn't mess up anywhere. So we've got 16 sine inverse sine of 1 minus 16 inverse sine of -1. And what does that come out to be? Huh? Use your calculator. What's 1 inverse sine? And inverse sine of -1. Huh? Degrees. I don't do pi to the what does it come out to be? negative 90, which would be 270. So you got 90 here, right? Minus 270, and your 16s are in there too, right? So that'd be, well, actually you pull 16 out too, can't you? And 90 minus 270 comes out to be what? Pi. Go you back around to the, I don't like to get it too negative. Now your 90 is right here, and you minus 270 be pi. Okay, maybe I'm missing something. This is 90 degrees, right? If I minus 270, will I not be back at pi? Yeah, pi. 2 pi. I'm sorry. I'm thinking of 2 pi. I'm sorry. You're right. You're right. Well, yeah, you're talking this way. This is surveying. We turn. I'm sorry. In the real world, you turn a negative angle this way. Yeah. But here you go the opposite. I'm sorry. You're right. You come out with negative pi, right? All right. Which we're not worried about it because you can't have negative work, so it's going to come out. You're going to end up having pi anyway. So this times pi, somebody work that out, and that's your base. That's your answer right there. Somebody crank it out because I didn't. I got pi times 1008. And I got different numbers. I got 8 and 4 instead of the. What did you come up with? 456,000 and what? 466,000. 8. Foot pounds to empty that tank.
So you would need a train to empty the tank.
A what? Well, you would have to, well, you got to remember, a pump is foot pounds. You can have a tractor hooked up to a pump. Oh, and it could pump crazy amounts.
That just goes into.
Yeah. Well, go online because we used to have one when we used to irrigate our truck farm. Hold on a minute, I'll show you. This is real world. I know I'm not supposed to teach real world, but anyway. PTO hydraulic pump. See? Now, these are internal, but you can actually get them to fit on the back of a tractor. Nope, those aren't. Those fit on the side of the transmission, like to work a dump on a dump truck. No. Let me do this. That's the hydraulic fluid. Let me do PTO, tractor-driven water pump. Tractor-driven water pump. There we go. Like that right there. You see that thing right there? And it's sitting on the back of a lawnmower. But let's look at the specs. Here's one that you dump into a pond right there. But I'm just saying, if you use something like that, let me do specs. What would we do without the internet? Here's a 2.4 horsepower one. I don't know if it's got specs on it, but they're probably going to give it into, yeah, gallons per hour. So gallons per hour, you'd have to convert that into what? Pounds, gallons per hour. Yeah, I'm just saying, I'm just trying to think how you would convert it.
You have to convert the weight of the gallon of water.
Mm-hmm.
And we have to find how much time it takes.
Take that up with your physics teacher. But see, think about this. 4,000 gallons per hour. How much does a swimming pool hold? Anybody have a swimming pool?
Ours is kind of big, it's like a 30-foot by 10-foot by 8 foot.
Well, how much is that? I mean, do you know how many gallons it holds? I mean, I'm just wondering. I think the swimming pool holds 2,000 gallons, doesn't it? I'm just, but think about that, 4,000 gallons per hour. I mean, that pump is pumping, and that's just a 2.5 horsepower pump. So you take a pump, I don't know what gas people use. Look up. I know we're on the internet. I know somebody's going to complain that we're looking up stuff, but this has to do with what we're talking about. So you can just go suck an egg. All right. Fuel. No. That'll look up fuel pump. Gas station pump specs. Gas nation. Gas in the station. I don't know what that is. Gas station fuel pumps. I'm looking to see if there's any with just specs. Gas station specs. I know we're not looking at what state or anything. I'm just looking to see if we can find some kind of, I don't see anything that says, no, they don't give anything. Well, you'll have to look it up, but I would be willing to bet that it's something like that. I mean, 4,000 gallons per minute. I mean, per gallon. But you got to transfer, and that would be something that we could talk about converting. What was it? Gallons per minute? Gallons per hour to, I can't type or spell, to pounds per what? Pounds per cubic foot? Your value, cubic foot per hour. No, that's not what we want. You'd have to convert it. But think about this. I have and I know this has nothing to do with what we're talking about, but I have a track hoe, and it's got these cylinders. They're rated, the hoses that go to these cylinders are rated at 15,000 pounds per square inch. It'll pick up a 5-6 ton bulldozer. Now you think about how much pressure is on that. I mean, some of this stuff you can't think about because one, you're not used to it, and two, it's hard to think about that stuff, period, even if you're used to it. 15,000. Can you think about 15,000 pounds per square inch? Can you fathom that? I can't. Now I can see that track hoe and this old piece of junk, but for the farm it does what it does. It'll take, I have picked up I think that 175 is 8 tons. Just picked up that 8-ton bulldozer because it was in a swamp and I couldn't get to it. And I just picked it up and I just set it. And it is the most surreal thing. I wish I took a video of it because it was just surreal seeing a bulldozer being picked up and moved over like wasn't nothing to it. But all because of those 2 cylinders, because I sure wasn't using the bucket because I would have busted a hose on the bucket because it's only rated at 4,000 pounds per square inch. So that you're talking about an incredible amount of pressure. That pump on the back of that thing is pumping to make those cylinders pick up 7 to 8 tons. And that's why engineers go through so many math courses, because you have to train yourself to actually what? Think like that. Because most people don't. So anytime y'all want to come out there and work, y'all come on out there and work, and I'll train y'all how to think like engineers. Huh? I don't pay anything. I'm kidding. I don't want anybody working for me. You know why? About 10, 15 years ago, you had somebody working for you, they would actually what? Work. Now, I don't want nobody out there on the farm because it's more babysitting than it is anything. Alright, let's do a nerd. Alright, this one is putting the 2 together kind of like a conic with this is called a trough. Like dang old feed trough, like dang old feeding livestock. Let me pull it up. I don't want to draw it because I can't draw. So let me pull one up. I'm going to let y'all work it because you've got the tools to work it now. I don't know how to spell trough. There's a good picture, but that's not what I want. Dang, they don't have a picture of it. They have a picture of everything else. Maybe I'm not looking it up right. Do trough tank. A dang old watering troughs. Let me do conic trough. I'll try that next. Let me do conic trough. If not, I'll have to go at drawing it. I don't like drawing. Okay, we'll go with a triangular trough. There we go. We're so smart. Alright, so there we go. Dang old save, dang old. Dang old, you ought to print some of these out so you won't have to draw them. Peace. Dang old, tell you what. Alright, here we go. So we got dang old trough, and those of you that don't know what a trough is what you feed animals with, or it's a long and pour stuff in. Okay? And this height is 3 feet. Length is 10 feet. And the width is 3 feet. I'm looking to see what kind of liquid I got. I think it's water. Cause I got displacement 62.5. Is that water? Somebody look it up. I think that's right. Water is 62.5. I don't know why I don't write it down. I guess I'm in a hurry trying to do it. And it's full because I'm going from 0 to 3. Or 3 to 0. So tell me how much work. While y'all are looking on that, I'll call the roll. 1, 2, 3, 4, 5, 6, 7. 4, 5, 6, 7, 8, 9, 10. Let's see how many people we got on the roll. Oops, sorry. Let me freeze that. Dang, I bought me a granola bar and ain't even ate the damn one thing. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. Missing one person. Who we missing? I'm looking to see if I know. Huh?
His name is Ross.
Oh yeah, hold on. Let me see if I can find him. Is it Mr. Robinson? Is that it? Let me see a picture. Oh, he don't have. Oh, yeah, that's him. He's not here. I don't understand how these pictures work. Sometimes they just pop up, and when I want them to pop up, I can't get them to pop up. Huh? Your ID that you took for your, yeah, they associate it with your name, so that way I can see who you are, so you're not sending somebody to class, you know, so you can sleep. I don't know why anybody would want to do that for somebody. Yeah, I'll get up at 8 o'clock to go to your class for you. Huh? Yeah. So Mr. Robinson is not here. Everybody else is here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay, that's done. So find the area or the volume of the slice. Well, let's look at this. Well, that sucks. Here we get the point. Didn't get that right there. So DH is your length, your height. This right here, we got to work on this because this is the related rate that we need. And of course the length is what, 10 feet? So the volume of the slice is going to be equal to 10 times something times DH. Now we just got to find something. So we've got a triangle, looks like that, and it's what? 3 foot by 3 foot, 3 foot here, and 3 foot here. So you could actually get a triangle, or you could set it up, you can set this up the same way, it doesn't matter. Let's call this H, and call this width. Okay, so 3 is to 3, as H is W is to H, and multiply both sides or crisscross. That's going to be 3H is equal to 3W. So what? H is equal to what? H is equal to W. So it's a direct proportion. So length times width, so the width will be H. I hope that's what I came up with. And yeah. And we're going to substitute 3 minus H into that H in a minute, so it'll work out. So, the volume of the slice is going to be that, and the force is going to be equal to 62.5 times the volume, which is 10 times H times DH. 10 times H times DH. And just remember that H we're going to change into 3 minus H when we get through or get close to it. Because your height right here is changing. Right here is 0. Here it's 1. Here it's 2. Here it's 3. Like that. Anywhere it's going to be 3 minus H. That's why all of these are going to be 3 minus H, or whatever minus H, because the part about calculus that's different from algebra is it's instantaneous. Each second, each little bit is H. There. In other words, that plunger starts off at 0, but right here it's at 3 minus 1. Here it's at 3 minus 2. Here's at 3 minus 3.
I would pushing the water.
Huh?
I would pushing the water like up.
Yeah. Yeah, I forgot to tell you, there's a spout up here, it's 2 foot, but we're not going to worry about that right now. We're just going to, there's a hole right here, we're just going to put a hole. Okay? Pump it out of that hole. So now, we've got force multiplied. Go ahead and put the displacement to H minus 3 or 3 minus H in there. So you're basically going to set up 0 to 3 of 62.5 times 10 times 3 minus H dH. And crank it out. So this one wasn't as hard as we thought.
Let me take this and see if I can copy this.
And of course, what are you going to do first? You're going to pull what out? Well, 625. You're not going to pull these two out. You're going to move that decimal. It'll be 625. Antiderivative from 0 to 3 of 3 minus h dh. And of course, that's going to be 625 bracket. And that's going to be 3h minus what? H squared over 2. Evaluated at 0 and 3. And of course, 0 does what? Goes out, right? So that's going to leave 625 brackets 3 times 3 minus 3 squared over 2. And that comes out to be 625 times 9 minus, what is that? 3 squared is what? 9 over 2, which is 4.5. Y'all check me. So 625 times 4.5. Dang old 2,500. Dang old 20, 25, 28. 2812.5 or something like that. What does it come out to be? Dang, we live in blind pig, 5 acre and 9. Foot pounds. What's wrong? Something ain't right?
No.
I thought you said something like right. If I did something wrong, let me know. I don't think I did. Okay. All right, let's try a simple one. This one wasn't too bad. But I'm giving you different problems to look at, and that way when you get to the homework, you won't go, at least some of you won't go, How about this one? You got a tank. This is the one y'all like. Why do y'all like this one? Because you don't have to think too much, right? Hold on, I'm thinking. Alright, I got to read my own writing. 10 meters. Oh God, this is metric. 10 meters. You got a spout at the top. That's 4 meters. Radius is 5 meters. I just did that. I'll just draw this and go to there we go. It's half full of water, and some some programs will go ahead and give you the 9800. Some will tell you it's 1,000. This is 1,000. Some will give you 98. So I'm just going to throw the 98 up there, so that way you're used to seeing it done that way. 9800. What is it? Newtons per meters cubed. And they want to know, they want to know how much work to get the water here. And I'll just say, get the bottom of the water to the top of the tank. Let me just say that, okay? Get the bottom of the water to the top of the tank. Why did I say it like that? Because if I say pump all the water out of the tank, some people will say, well, there's still water in here. Okay? So I'm just going to say pump the bottom of the water to the top of the tank. Or push it. I think I give you all the information you need. The only one I haven't covered is a spherical. And I'd like to show you one that I would put on a test. Y'all would like that, wouldn't you? I don't get overly excited about anything really. I think there's a half of one, half a sphere. Let's see what y'all got in y'all's homework. Well, have I done spheres yet? Homework? Y'all need to settle down and be quiet. Hubert's work in other tanks. I think that's the one I put springs on too, because they haven't covered springs. We'll cover that. Look and see what I can find there. Class view. Not going to show it to you. Alright, I'll just wait until next time to go over the sphere. Set this one up. And I've got 4 minutes, so. basically the work is going to come out to be, and I'm just going to write it for you because some of y'all are having cardio infarctions about leaving, so. It's going to be the anti-derivative from 0 to 5. Because you basically, the work that you're going to do is going to be pumping from here to where? There. What are you pumping? Okay, what are you pumping? What are you pumping? When you lift this up right here, what are you pumping? Air. Remember that, okay? You're pumping air. So you got to wait until you get to right here before you start the work. Why? Because that's when you're pumping what out of the hole? Yeah, but they're not asking you about that. They're asking you about pumping the water out of the tank. All right?
So it's all in the lunge of that concept.
No, it would not give you different value. It gives you more, bigger value. You're pumping the water right here. Okay, here's where it touches the top of the tank. All right, where are you starting at? 0. And you're moving 1, 2, 3, 4, 5. One of the hardest things for people to understand is that part right there. First part is the actual related rate. You know, where you set it up. That's the first part that people have a hard time with. The second part is the distances. So just what you need to do is you just need to think and say, okay, am I pumping water right here? Am I pumping water out of this tank? No, you're not. You're moving it, but are you pumping it out? Boom, right there is where you start. Because right now, the top of the water, here's the water, is where? Right here. It just has gotten to this point. You have to think of that. Remember the push-up? You have to think about it. You're not getting any ice cream out of the top of that push-up until you get this to the top. So 0 to 5. And when you do the 9,800 times everything, you're going to come up with 24,500 pi times 14 minus y dy. That's the setup. And that 25,400 basically comes from 25 from pi r squared. So that's where that's coming from. And because what's your R? 5, so that's 25. What's 25? What's 25 times 9,800? We'll be close to that. Somebody check me. Huh? Yeah. All right, work on that. And when y'all come back, we will work on spherical tanks, Hooke's Law, and see what else we need to go over for the test. And this will be a kind of a review / Unit 1 test. How you feeling about that? Let me ask you a question. Some of y'all that's had Calc 2 before, you've been through tanks. How is it now? Just as hard. Okay, thanks. That really helps my self-esteem. I try to break it down as much as I can.